Well, hi there YouTubers, Jose Quiñones the CNC Dude. I just got me here another IAI, I think these guys are called intelligent actuators or robo something. I'm opening it up. I paid $65 for this guy, and my reasoning was, man, I cannot even buy the ball bearings for $65. So to me it's a good deal. Of course this is used, most likely heavily brutalized, and I know a fairly decent amount of viewers will say, well, this is a piece of junk because this is aluminum, so it's not very stable, not very robust. But I'm certain there are plenty of applications for which this is excellent. And for $65, I think it was $70 with tax. So I mean that included shipping and everything. Man, there is no way to go wrong with that. So I'm gonna open it up, and the goal here is to change the motor because this is a brushed DC motor, which of course, I mean, I could drive a brushed DC motor. I can do all of the servo stuff. That's too much work. Let's just go ahead and change the motor and make it work with a stepper. Alright, I was able to remove this guy. Clearly this is a brushed DC motor with a chaff encoder. It says 60 watts, 30 volts. It's a conventional brushed DC servo. And the other thing that I wanted to show, I mean, this is a ball screw here. It's supposed to be a fairly accurate system. Moves very nice. There's no way you're gonna get those parts for $65. I mean, not even Chinese made you're gonna get all of these for $65. So I think it was a good deal. I'm gonna show you how it looks on this side because it's very interesting what they've done. Now obviously the motor goes into this side. Let me move this a little bit so you see what I'm talking about. I'm gonna put the camera on this side shortly so you can see what's going on here. But obviously the motor goes on this side, the lead screw or ball screw goes on this side. So obviously there is a belt that transfers the motion from the motor to the linear actuator. A few things I want to mention about that. Some of the IAI intelligent actuators that I have opened up, they have the motor on this side, so they're direct driven. A reason for why you would not want to do direct driven, actually I can think of two reasons. One of them would be space. If this is already too long and you know whatever it is that you're building has the machine equipment on this region, and then you cannot put a motor in here, that would be a reason for to do it like this. But I think in this case it's pretty obvious that there is a reduction. So the gears or the pulleys in this case are of different diameters, so the motor is gonna get the power out of the motor is gonna get transformed in terms of speed and torque. So those are the two reasons on why you would want to do it like this. As I was saying, here is the motor pulley. This is a timing belt. I have no idea what kind of pitch or anything. And here's the linear rail pulley. So there is a conversion. I gotta do my numbers because I don't remember what happens when you go from small diameter to large diameter. But if I do a quick math on my head, I imagine that we're reducing speed because this guy is gonna need to do many turns before this guy do one turn, right? That's kind of obvious. That means that you're reducing the speed, but you're increasing the torque. That's a fairly simple thing. Whenever you reduce one, the other must increase. Do note, however, that there's going to be some losses. You're not going to get all of it. Of course, there's going to be friction, slip, all that crap. So it's not perfect. Nothing is perfect in this universe, but that's the premise. So if I can put my stepper here, that would be fantastic. I have removed the motor, and you know, most likely I'm gonna have to redo this whole thing because it's very hard to believe that I'm gonna be able to take advantage of those 4 holes. I mean, I haven't measured yet, so maybe by pure chance I can put a stepper in there, but I completely doubt it. I mean, it's pretty obvious that this is not gonna be a good match. I just wanted to show a few of the features that I'm gonna have to copy. Of course, I'll need to mount the motor here, so I'm gonna have to measure the distance from this axis to this axis, because that's gonna be crucial. But very interestingly, there is also canals in here, pockets, to move this guy in and out, and that's for belt tensioning purposes. But that, you know, all of this is kindergarten stuff, so that's pretty straightforward. If you have a milling machine, of course, if you want to do this with a Dremel, that's a different matter. But if you have any kind of a milling machine or a CNC milling machine, this should be kindergarten technology. Okay, I was able to remove the plate. Man, this being this being pre-kinder stuff. This has been so easy. I'm actually amazed. Sometimes opening these guys up is a mess and just start losing ball bearings, but this is just gorgeously easy. All I need is to copy this profile. Now I could go and get busy with my caliper and start making measurements, but I'm gonna cheat. I'm gonna be a lazy bastard, and what I'm gonna do is I'm gonna scan this with my computer scanner. Then I'm gonna get a picture. I'm gonna put it on a Corel Draw, and in Corel Draw I'm gonna measure all of these features, and then I'm gonna make my drawing on Inventor. And of course this information is useless for me, but everything else is what I need. So now you may be thinking, well, if you take a picture, how accurate is that gonna be? Well, you know, I don't need microns here. We're not trying to match the atomic content of this guy, so it's gonna be good enough. That's all I need. Good enough is all everybody needs. All right, a quick detail on what I'm trying to do here. This part is gonna be close to 9.5 inches in width, and of course I don't have a vise that is thick enough, or width enough I should say, and I think for something like this most people would have had two vices. I don't have two vices. This is probably the first time that I need something with longer footprint. Actually, I take that back. This is probably the second time. But you know, no biggie, because the thing is that I am not into making many of anything. So truly, I think I would have spent way much more money and time setting up two vices than it is to figure out how to do it what you have. And in this case, what I've done is I'm using a bunch of the blocks, the 1, 2, 3 blocks, and you know, they have threads. In this case, I think they are 3/8 if I recall. So I just put some screws and I jacked it up. Now the sole purpose of this is to a support, and you know, maybe I don't even need this, but I think I will, because there's gonna be some deflection here when the tools come down. So just to be sure, you know, now I have some support. This is not doing a lot of stuff in the upward direction. All I want to do is add a little bit of support to make sure that it doesn't deflect a lot. And you know, if the screws gets busted, who cares? I mean, these are cents. It's not going to be the end of the world at all. Most likely, I'm not even going to touch these screws anyway. But if I do, I don't care. So that's going to be the setup. Now let's do some cutting. Alright, a little change of plans. On a different video, I'm going to document a little bit about this soft joist that I had to put in place, because the problem is that the width of this part, which is 4 inches, and the width of the part that I want to make is like too close. So I was fearing that my cutters were going to cut into the hard joist, the steel joist. So definitely you don't want to go there if you can avoid it, for sure. So now I have soft joist. You know, if this gets mangled, who cares? That's what they're there for. Other than that, it's pretty much the same thing. I still have my jacks. I cranked them up a little bit just to make sure I wasn't gonna get them loose because of vibration. That's still a possibility. I've never done this before, so let's see what happens. Oh, here we go. This is the original part, and this is the copy. Now, I started doing a little bit of fitting, and it's looking really good. But there were a few mistakes. I'm not certain how I missed this. Let's see. These holes are where they're supposed to be. I don't know if you can see that. Let me put it like this. These holes are where they're supposed to be. Don't mind this, because remember, these 4 holes are for the brush DC, but I'm gonna put a stepper, so clearly I need larger holes and different spacing. However, I somehow miss a bunch of these holes. Let me see, man, this is tough to align. All of these are looking good. This is looking good. This is looking good. This is looking good. But for some reason, these 4 holes are in the wrong place. I am a little bit surprised about that. How the heck did I miss it? I think what happened was that, of course, I did the wrong thing for sure. But the thing is that I double checked, and I could have sworn that everything was okay. But I don't care about those 4 holes actually, because those 4 holes are for this guy. And I'm not gonna reuse this anyway, so everything is okay. Now what really matters is this feature here, and these 4 guys. That's what truly matters. So I already know that everything came out as it should, but I'm gonna show you. Motor is in. Motor is in, man, it just sat perfect. I mean, there is no play at all. This is gonna be awesome. Next step, I'm gonna need to get the pulley before I can start assembling this guy. I have removed the DC motor, and I'm going to reuse the pulley. Now, a problem with these guys, there is a set screw here. That's the easy part, it already came out. But there is also a pin going through. So I'm gonna have to remove that guy, and you know, they are put in there to stay, so clearly that's not gonna be easy. And I'm not saying that removing a pin is hard. The problem is removing a pin while this guy doesn't move. So I'm gonna try to put this guy on a vise, such a way that this is perpendicular, and I can somehow, with a press, take it out. But you know, the tricky part is pressing it without crushing this, and in such a fashion that this guy is perpendicular, because if it is at an angle, how are you gonna make the force, right? So truly crucial that I can attain both things at the same time. So I think this is gonna be the hardest part of the whole project. I don't even recall where I got this vise. It was given to me at some point in time. I think it was given to me when I bought the second Tormac. That doesn't sound right. I think I bought this on the Craigslist with something else. Anyway, this vise is I think it's a palm green. It says Iran, but it's kind of the palm green style. And I was able to grab this guy, and I think it's fairly stable. Now I'm gonna use the press to push down on it. Let's see how that goes. Well, here it is. I was able to take it out, but I gotta tell you, the press was a freaking nightmare. Completely useless. The problem is that if you don't get the force perfectly straight, stuff starts to bend, and it's what a freaking nightmare. So I just use one of these guys. We call it a transfer punch, a hammer. And I know Mr. Pitt is gonna be super mad at me, because that makes me a chisel mechanic. Hammer and chisel mechanic, or chisel and hammer, whatever is the order. But you know, it's out. So this is what I need. It looks great, so I'm happy. Alright, after all of the turmoil that I described earlier on the pulley, we're ready to put it here. And the reason why I need to put the pulley first is because I don't have enough play to install the belt. What's gonna happen is, as I install this guy in here, I need all of that play so that I can put the belt. Once the belt is in place, then I can put the other 4 screws. And there you have it. For all practical purposes, we're ready. We have changed a brush DC motor for a stepper. We have a linear actuator. It's looking fantastic. Of course, I will power this up, and then I mean, we'll get some motion. I'm positive of that, but it's looking great so far. Well, I have been able to plug it in. I gotta say, that I had to spend like 2 or 3 hours just to connect this guy. Not because there's any complications in plugging a stepper motor, but just because, you know, we moved barely 7 months ago, and I am still going through crap that took me months to pack. So the computer and all of the system that I used to drive my CNC machines, that was, man, finding all of those components, it took a while. But regardless, we have motion. So it's gonna make for an awesome axis for a CNC machine. And man, I have not done, let's see, how do you do? Nice. There you go. We have a full-blown axis. Now all I have to do is put the other one on top of here, which is gonna go like this, or whichever. I don't know. Maybe I put this on top of a longer one, and now this goes like this, and the whole thing goes like this. Regardless, I mean, that's a project for a different day. We have it. We have been able to change from brush DC motor to stepper, so this axis has been revived, and we're good to go. Thank you for tuning into my YouTube channel. More to come on this project, so keep tuned. Have a good one.